This is section 6.8 on graphing radical equations. We're going to start with the most basic radical equation, which is y equals square root of x. Just to take a look at what the graph's going to look like here. We can make an xy chart. First of all, if I plug in any negative numbers, if I plug in -1 or -2, I get undefined on the real number plane. So there's no x values that we can plug in here. Our domain is just positive numbers or 0 can be plugged in for x. I can plug in 0. Square root of 0 is 0. I can plug in 1. Square root of 1 is 1. I could plug in 2. Square root of 2 exists, but it doesn't come out even, so we're not going to plot that point. Same with 3, but 4 comes out even, so let's plug in 4. Square root of 4 is 2. Next number I could plug in is 9. Square root of 9 is 3. That should give us enough points to draw a decent graph. So I've got a point right here, 0, 0, 1, 1, 4, 2, and 9, 3. Remember, I don't have any negative x values, so it doesn't come over here into the negative x's. I also don't have any negative y's, so it doesn't come down at all. It just stops right at that point. This is half of a sideways parabola. So this is kind of our basic thing we're going to do. We might have translations, and we'll have a parent function like we did with other types of graphs, but then we're going to plug in 0, 1, 4, 9 in for x, get our y's, and draw our graph. So I'll call this example 2, ask us to graph y equals -2 times the square root of x plus 5. Y equals -2 times the square root of x plus 5. Let's go plus 3 tacked onto the end here also. So first thing we want to do is identify our translation. So our translation is left 5 and up 3. Left 5, up 3. Our parent function is the same as the original function, but take out the translation. So if we take out the up 5 or left 5 and up 3, we're left with y equals -2 times the square root of x. We're going to plug in points into our parent function. Because it's square root of x, good numbers to plug in are 0, 1, 4, 9. And we're plugging them into the parent function. Square root of 0 is 0 times -2. 1 times -2. Square root of 4 is 2 times -2. 3 times -2. And then like we did with quadratics, we do our translation, left 5, up 3. And then from that translated point, we went left 5, up 3. And then from this point, we plot these points. 0, 0, 1, -2, 2, 3, 4, -4, and 9, -6. 3, 4, 5, 6, 7, 8, 9, -4, 5, 6. Again, it just comes to this point right here and stops. And our graph looks like that. Let's do one more, example 3. Let's go y is equal to 2 times the cube root of x plus 1 minus 4. Y equals 2 times the cube root of x plus 1 minus 4. This one's going to turn out just a little different because it's a cube root. Translation, left 1, down 4. Parent function, take out the translation. 2 times the cube root of x. Set up an xy chart for the parent function. If it's a square root, we plugged in 0, 1, 4, 9, because those are perfect squares. They came out even. Here I have a cube root. I am allowed to take the cube root of negatives. So cube root of -8 would come out even. Cube root of -1 comes out even. 0, 1, 8. I'm plugging in perfect cubes this time. And you are plugging them into the parent function. Cube root of -8 is -2 times 2. Cube root of -1 times 2. 0 times 2, 1 times 2, 2 times 2. Do your translation, left 1, down 4. And then from that translated point, you plot these points. So from this point, I'm plotting -8, -4. From this point, I'm plotting -1, -2, 0, 0, 1, 2, 8, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Because this one is a cube root, it does not stop at this point because we can't have negatives. So I missed that point, obviously, but the general graph looks like that guy there. Reach out if you're having questions. There will be an assignment to complete as well.